Okay, this is our introductory lesson to trigonometric functions. So this is chapter 5, and this is where we'll start our unit on trigonometry. So today we're just going to be going over a couple of basics related to trigonometry, and then eventually we'll start using applications where we'll use trigonometry to solve for some certain unknown values, hopefully using different types of applications, word problems, physics problems, things like that. The first thing we have to do before we can talk about any kind of trigonometry is to talk about angles a little bit, because angles are really important in trigonometry. So what is an angle? An angle really is just, if you can imagine a line that moves in a certain direction a certain amount, right? So we've got an initial side, and then that initial side moves. You can see the initial side here, and then it moves up this angle alpha, and then it ends, right? And then what do you call it when something ends? You say it terminates. So that's the terminal side. So we've got this angle. Right. We've got this angle alpha, or you can call it theta, or you can call it x, you can call it whatever you want. And this moved up here until it stopped over here, and that became the terminal side. And then this is the point that it rotates around, and this is called the vertex. So you've got a line, and it starts at a certain place, right? And then it rotates. So there's two ways to rotate, right? We've got rotating against the clock, which is known as counterclockwise. And then we've got rotating in the same direction of a clock, which is known as clockwise. If you rotate something counterclockwise in the coordinate plane, then it is considered a positive angle. So if my line started here, and then it rotates this direction and ends here, right? This is the terminal side. Then we say that this is a positive angle measurement. But if we rotate the opposite direction, if we rotate our line, so now my line starts here, and this time my line rotated in the opposite direction, so counterclockwise, then we would give it a negative angle measurement. So we would call this negative 230 degrees. So the other thing that's important in addition to which way you rotate your line, if you go clockwise or counterclockwise, is the position of the angle. So we're going to be making angles in the coordinate plane, and it's really important that these are what's called standard position. So standard position has to be two things. Number one, the initial side always has to be the positive arm of the x-axis. So you'll see that here and here and here. Right? Wherever that line is, it always starts on the positive side of the x-axis. And the second thing is that the point that we rotate around, or the vertex, always has to be the origin. So you note that we start here, we rotate around the origin, and then we end over here. That's the terminal side. So start on the x-axis, rotate counterclockwise, and end over here. That's the terminal side. And same thing over here. So we have an angle. It's got an initial side and a terminal side, and the distance between those is the angle. It can rotate clockwise or counterclockwise, and we also have to put the vertex, the point that it's rotating around, that always has to be at the origin. So those are the two conditions that put an angle in standard position in the coordinate plane. Okay, so when we rotate in the coordinate plane, one thing that we notice as we start to work in the coordinate plane doing rotations is that essentially we're rotating with a part of a circle, right? Everything is some rotation is some part of a circle. And so the maximum amount that we can rotate if we go all the way around is 360 degrees. So why do we have 360 degrees? Well, it actually goes all the way back to the Babylonians. And the Babylonians are an ancient empire that you can see this is Egypt over here, and this is Saudi Arabia. So it's just north of Saudi Arabia, and it actually was a fairly big area. That was the Babylonian Empire. And the Babylonians were credited with a group of other people, the Sumerians, and they invented writing. And they were actually very intelligent. They studied astronomy, and one thing that they noticed is that it took about 360 days for the sun to complete one cycle in the sky. So they were essentially trying to figure out how long was 1 year. And they were pretty close, right? It's actually 365 and 1/4 days. But essentially that was their year, 360. And so they saw a year as being like a circle, and therefore our circles are broken up into 360 days, and that made sense for them to break up a circle into 360 parts. So later the Greeks came along, and this is Greece over here, right? This area over here. So later the Greeks came along, and they actually broke a day up into 24 hours. And then the Babylonians, who had what's called a base 60 number system. Okay, basically that means they had 60 different numbers before they started counting over again. We have a base 10 number system. The Babylonians, who had a base 60 number system, decided that they would take that day, which was 24 hours, and they would break up the parts of those hours into 60 parts. So that's how we get 60 minutes in an hour, and that's how we get 60 seconds in a minute. And the Babylonians, they assigned the same sort of counting or breakdown to circles. You've got a circle, that circle breaks into 360 degrees, and in the same way that they broke down hours into minutes and seconds, they broke degrees also into 60 minutes, and then each minute into 60 seconds. So what that means is that instead of just having, a 1 degree shift, we can actually break that degree into smaller and smaller parts so that we can be more accurate. This is, of course, important in terms of navigation. But we have, you can see 12.520. That's 52/100th of a degree. That's in our base 10 number system, 52/100ths. So we can convert that into degrees, minutes, and seconds, which is like base 60. So the first thing we want to do is look at the part or the portion of the degree that we have. So we were given this portion of a degree, which was 52/100ths, right? And we can take that decimal portion of the degree and multiply by 60, since there are 60 minutes in a degree. And that gives us 12 degrees and 31.2 minutes. Now, again, we've got this 0.2 minutes. So we can take the decimal portion of the minutes, and we can find out how many seconds that is by multiplying the decimal portion of the minute by 60, 60 seconds in a minute. So we always take the decimal portion and multiply by 60 for 60 minutes and 60 for 60 seconds. We get 12 degrees, 31 minutes, and 12 seconds. So we're basically rewriting something from base 10, or a decimal, and writing it in base 60, or minutes and seconds. So here's a way of expressing this as minutes and seconds, degrees, minutes, and seconds. And now we want to convert it back the opposite direction. So how do we do that? Well, we've got 24 degrees. We're not going to do anything with that. But this 15 minutes and this 33 seconds, we need to convert that back to parts of a degree. So the question is, what part of a degree is 15 minutes? Well, it's 1/60th of a degree. So if we multiply 15 minutes by 1/60th, then we'll convert it back into degrees. Same thing with 33 seconds, except this time we have to multiply by 1/3600th. Why? Because there are 3,600 seconds in a degree. Right? Each minute has 60 seconds. Each degree has 60 minutes. Therefore, there are 60 times 60, or 3,600 seconds in a degree. So we multiply by 1 over 3,600. So now we have a way of converting from minutes and seconds back over to base 10, which is 24 degrees and 259 thousandths of a degree. So here's a place for you to pause the video and practice this. Okay, so I want you guys to practice numbers 5, 6, and 7, 8, 9, and 10, working backward and then forward from degrees, minutes, and seconds. And then stop and check in with somebody. And when you're ready and you ask your questions, then you can resume the video and move on. Okay, so now we're going to talk about what happens when the terminal side of the angle falls on one of the axes. This is an interesting vocabulary word, but it's not really that interesting of an idea or a concept. So this quadrantal angle, where does this word quadrantal come from? Well, it comes from the word quadrant, right? Because you can see that when the terminal side of the angle falls on one of the axes, it forms 1/4, or in this case, 1 quadrant, 1/4. This one's 2/4. Of course, this makes a quarter over here. And this one is the full 360 degrees. So we've kind of talked about how to make 360 degrees as you move around the circle. Remember that this one's negative because we're moving counterclockwise. So now we can look at drawing some different angles in the coordinate plane by just sort of following this idea. So a full circle is 360. Break a full circle into quadrants, or 360 into 4, and that gives you 4 90-degree segments. So sketch each angle in standard position. Remember, that means start here, and then if it's positive or negative, means we have to move in the appropriate direction. Right. So we're going to go negative 200 degrees. So if a full circle is 360, that means that I'm going to go back 200 degrees until there's only 160 degrees left. So what does 160 degrees look like? Well, we know that this much is 90. Each quarter represents 90. And so 160 probably looks like this. Now this is going to be negative 200, and that means this is going to be 160. Now if you look at the next one, in this case we've got 450. Now 450 is more than 360, which means we went more than a full circle around. So to figure out how much more we went around, we can subtract 360, and that leaves us with 90, which means we started here on the initial side. We went counterclockwise a full 360, and then we went 90 more. And this is the terminal side right here. Now 800. 800 is way more than 360. In fact, it's more than twice 360. So that means that if we subtract 720, or 2 times 360, we're still left with 60 degrees. So what must have happened here? We can start with the terminal side. We can go 360 all the way around. We can go another 360 all the way around. That gives me 720. And then I need to do an additional 60 degrees. So I go another 60 degrees. And I end up right here. So hopefully you get the picture about how to draw these types of angles. Okay, so this brings us to an interesting idea, and that is that there are multiple ways of representing angles in the coordinate plane. Like if I can spin around and around and get to the same place, then each place in the unit circle can be represented by different angles. So basically you can take any angle and you can either get there by adding multiples of 360 or subtracting multiples of 360. So for instance, if I want to get to this place right here, I can get there by rotating 50 degrees, or I can spin all the way around and pick up 360 and then another 50 degrees. and that gives me 50 plus 1 rotation of 360, or 410. So these